Before the first footprint touched the moon, it was simply a glowing light in the night sky. It inspired poets, guided explorers across oceans, and filled ancient civilizations with stories of gods, monsters, and impossible dreams. For thousands of years, humanity looked up at the moon and wondered one simple question: what is it really for? Today, that question has become more important than ever, because something extraordinary is happening. Governments, billion-dollar companies, and the world's most advanced scientists are all racing toward the same destination. They're spending billions of dollars designing futuristic spacecraft and planning permanent settlements on a world where there is no air to breathe, no rivers to drink from, and temperatures swing from blistering heat to freezing darkness. Why? Why would anyone want to build cities on a lifeless rock nearly 240 Zarosan miles away? What do they know that most people don't? The answer might completely change the future of humanity. Because the moon isn't just another destination, it could become the center of an entirely new civilization. Imagine a future where enormous spacecraft no longer launch from Earth. Instead, they quietly lift off from giant spaceports built across the moon's dusty surface. Massive cargo ships loaded with fuel, minerals, satellites, and supplies travel between planets as routinely as cargo ships cross oceans today. Mars asteroid mining stations, space hotels, even missions to the outer planets, every one of them begins with a stop on the moon. It sounds like science fiction, but the first pieces of that future are already being built. Over the next 30 minutes, we're going to uncover the moon's secret plan. Not because the moon has a mind of its own, but because humanity is slowly transforming it into something far greater than anyone imagined. By the end of this journey, you'll understand why many experts believe the moon may one day become the most valuable place in the entire solar system. And once you see the evidence, you'll never look at the moon the same way again. Let's begin. For decades after the Apollo missions ended, the moon seemed forgotten. Humans stopped visiting. Funding disappeared. The world's attention shifted towards space shuttles, satellites, and robotic missions exploring distant planets. Many people assumed the moon had already served its purpose. We had landed there, collected rocks, planted flags, taken photographs, mission accomplished. Also, it seemed, hidden inside those grey rocks was a secret that scientists would only begin to understand years later. The moon wasn't empty. It was filled with opportunity. The first clue came from something incredibly ordinary: dust. The moon is covered by a thick layer of fine grey dust called regolith. At first glance, it looks completely useless. Apollo astronauts hated it. It clung to their suits. It scratched equipment. It floated into spacecraft and caused endless problems. But modern scientists looked at that same dust with different eyes. Inside that powder are oxygen, silicon, aluminum, titanium, iron, and other valuable materials, not in pure form, locked inside minerals. If future technology can efficiently extract these elements, astronauts may no longer need to transport enormous amounts of construction material from Earth. Instead, they could build directly from the moon itself. Roads, landing pads, habitats, factories, even giant telescopes. The moon could slowly manufacture its own future, and that's only the beginning. Then came one of the biggest discoveries in modern space exploration: water. For years, scientists believed the moon was bone dry. Then spacecraft equipped with sophisticated instruments began detecting something unexpected: frozen water hidden inside permanently shadowed craters near the lunar poles. Places where sunlight has never reached for billions of years. These craters are among the coldest locations in the solar system, colder than Pluto. Inside them lies ice that has survived since the earliest days of the solar system. That discovery changed everything, because water in space is worth far more than gold. Water keeps astronauts alive. Water grows food. Water cools equipment. But perhaps most importantly, water can become rocket fuel. Using electricity, water molecules can be split into hydrogen and oxygen. Hydrogen burns. Oxygen supports combustion. Together, they create one of the most powerful rocket fuels ever used. Imagine producing fuel without ever leaving the moon. Instead of launching every drop from Earth, a process that costs enormous amounts of money, future lunar factories could manufacture fuel directly where spacecraft need it. That changes the economics of space forever. Launching from Earth is incredibly difficult. Every kilogram matters. Earth's powerful gravity acts like an invisible chain, holding every rocket down. To escape it, rockets must burn massive amounts of fuel. Most of a rocket's weight isn't cargo. It isn't astronauts. It isn't scientific equipment. It's fuel. An astonishing amount of fuel. But the moon has only about 1/6 of Earth's gravity. That means launching from the moon requires dramatically less energy. Imagine trying to throw a baseball while standing underwater. Now imagine throwing the same baseball while standing on dry land. The second throw is much easier. Spacecraft leaving the moon face a similar advantage. Less gravity, less fuel, lower costs, longer missions. Suddenly, destinations that once seemed impossibly far away become much more practical. This is why some engineers describe the moon as a giant stepping stone, not the final destination, the beginning of everything. Picture an airport. Passengers don't usually fly directly to every city on Earth. They stop at major hubs. Those hubs connect the entire transportation network. The moon could become exactly that. A transportation hub for space. Cargo arriving from Earth. Fuel produced locally. Supplies assembled. Spacecraft repaired. Then launched toward Mars, asteroids, or even deeper into the solar system. Instead of Earth doing all the work, the moon takes over much of the heavy lifting. But if this vision is so promising, why hasn't it already happened? The answer is surprisingly simple. Technology wasn't ready. For decades, building permanent lunar infrastructure was almost impossible. Computers were slower than today's smartphones. Robots were primitive. Reusable rockets barely existed. Every mission cost enormous amounts of money. A single mistake could end an entire program. Now everything is changing. Artificial intelligence helps design spacecraft. Advanced robotics can perform dangerous tasks. 3D printers can create tools and building components on demand. Reusable rockets have dramatically reduced launch costs. Private companies are competing alongside national space agencies. The race has started again. Only this time the finish line isn't planting another flag. It's building an economy. And wherever an economy begins, the United States has announced ambitious plans to return astronauts to the moon. China is developing its own long-term lunar ambitions. Europe, Japan, India, Canada, and several other nations are expanding their lunar programs. Private companies are proposing lunar habitats, mining equipment, communication systems, cargo landers, and transportation services. Everyone seems to be preparing for the same future. The question isn't whether people will return. It's who will build the first permanent foothold. History teaches us something fascinating. Whenever humanity discovers a new frontier, everything changes. The oceans reshaped global trade. Railroads transformed continents. Air travel connected the world. The internet created entirely new industries. Every revolutionary transportation system changed civilization itself. The moon could become the next great leap. Not because it's beautiful, not because it's close, but because it may unlock destinations we've never been able to reach before. And this raises an even bigger question. If the moon becomes the center of humanity's expansion into space, who controls it? Who owns the resources? Who decides who gets to build there? And what happens when billions or even trillions of dollars are at stake? The answers are far more complicated than most people realize, because beneath the quiet surface of the moon, a new kind of race has already begun. Not a race for glory, a race for the future itself. The race to return to the moon is often described as a race to plant another flag. But flags aren't the real prize. Location is. If you could look at the moon from high above, you would notice that not every region is equally valuable. Most of the surface is exposed to 2 weeks of relentless sunlight, followed by 2 weeks of complete darkness. That cycle creates enormous engineering challenges. Equipment must survive scorching temperatures during the lunar day and freezing conditions during the lunar night. But near the moon's poles, something remarkable exists. Certain mountain ridges are illuminated by sunlight for most of the year. Scientists sometimes call them peaks of near eternal light. Just a few miles away, deep craters remain in permanent darkness, preserving ancient ice that has never melted. Imagine building a city where your solar power station sits on a sunlit hill while your water supply lies hidden inside a frozen valley nearby. It's almost the perfect combination. That is why these regions have become some of the most valuable real estate beyond Earth. One day, the first permanent lunar settlements may compete for these exact locations, not because they are beautiful, but because they offer the greatest chance of survival. Energy, water, stable temperatures, everything a future colony needs. And once a colony is established, something even more exciting begins. Industry. When people imagine factories, they picture smokestacks, conveyor belts, and busy workers. But the factories of the moon will look nothing like those on Earth. Many may be almost completely automated. Robots will move day and night without needing air, food, or sleep. Artificial intelligence could coordinate thousands of machines working together with incredible precision. Excavators dig the lunar soil, processing plants separate useful materials. Massive 3D printers transform those materials into walls, pipes, landing pads, and replacement parts. Instead of waiting months for supplies to arrive from Earth, astronauts could manufacture what they need almost immediately. A broken wrench, a replacement valve, a damaged solar panel frame, even entire buildings. The ability to make things locally changes everything. Think about the earliest human settlements on Earth. At first, explorers depended on supplies brought from home. But permanent civilizations only appeared when people learned to use local resources. The moon must follow the same path. No civilization can survive forever if every screw, every brick, and every drop of water must be launched from another planet. Self-sufficiency isn't a luxury, it's a necessity. And this is where the moon begins to reveal its greatest strength. It isn't simply a destination, it's a construction site. Everything built there makes the next project easier. The first landing pad reduces dust for future missions. The second habitat houses more workers. The first power station supports larger factories. Those factories produce more equipment to expand the settlement. Each achievement accelerates the next. It's a chain reaction, a snowball rolling downhill, growing larger with every turn. Eventually, the moon stops depending on Earth. Instead, Earth begins depending on the moon. That idea sounds impossible today, but history is filled with places that transformed from remote outposts into economic powerhouses. The same pattern could happen again. Only this time, beyond our planet, Now imagine standing inside one of these future lunar ports. Above you, enormous cargo spacecraft wait on launch platforms. Some are heading toward Mars, others are carrying scientific equipment to giant space telescopes. A few are transporting mining robots toward nearby asteroids. Every departure follows the same routine: fuel produced on the moon, maintenance performed on the moon, cargo loaded on the moon. The moon has become the logistics center of deep space exploration. This is where the title of our story begins to make sense. The moon isn't conquering the solar system through force. It is becoming so useful that every major mission naturally passes through it. Just as major seaports became essential during the age of global exploration, the moon could become the crossroads of interplanetary travel. Ships don't stop at great ports because they have to. They stop because it saves time, money, and resources. The same principle may guide space travel. But transportation isn't the only opportunity waiting on the lunar surface. The moon may also become one of humanity's greatest scientific laboratories. Earth is a noisy place. Our atmosphere scatters light. Radio signals fill the sky. Weather constantly interferes with observations. The moon offers something different: silence, especially on the far side. The far side of the moon always faces away from Earth, creating one of the quietest radio environments in the inner solar system. Imagine building radio telescopes, their machines so sensitive they can listen to whispers from the earliest moments after the universe was born. Astronomers dream about this possibility. Without Earth's constant radio interference, they could study cosmic events that remain hidden today. The moon may help answer questions we've been asking for generations. How did the first stars form? What happened shortly after the Big Bang? Are there signals we've simply been unable to detect? Sometimes exploration isn't about finding new places. It's about seeing old mysteries with new eyes. The moon could become humanity's greatest observatory. And then there's another possibility that sounds even more extraordinary: asteroid mining. Scattered throughout the solar system are countless asteroids containing enormous quantities of metals and minerals. Some contain nickel and iron. Others may hold platinum, group metals worth unimaginable amounts on Earth. A few even contain water trapped inside their rocky structures. Launching mining expeditions directly from Earth is expensive. Launching them from the moon could be dramatically cheaper. Imagine fleets of robotic spacecraft leaving lunar spaceports, traveling to nearby asteroids, extracting resources, and returning to the moon for processing. Instead of shipping everything back to Earth, many of those materials might be used in space itself, building satellites, constructing massive space stations, manufacturing solar power systems, even assembling giant spacecraft far too large to launch from Earth in one piece. Space would no longer rely entirely on Earth-based industry. It would have its own economy, its own supply chains, its own infrastructure. That possibility is attracting attention from governments and private companies alike. Not because profits are guaranteed. Far from it. The technical challenges remain enormous. Mining in space has never been done on an industrial scale. Every new technology carries risk, unexpected failures, huge costs, years of testing. But history shows that every revolutionary industry begins with uncertainty. The first airplanes seemed unreliable. The first automobiles looked like expensive toys. Early computers filled entire rooms while performing calculations slower than today's watches. Innovation often looks impossible until suddenly it becomes ordinary. The moon may be standing at exactly that point in history. Right now, engineers are solving problems that future generations may never even think about. How do you keep machines operating through freezing lunar nights? How do you protect astronauts from dangerous radiation? How do you prevent abrasive lunar dust from damaging equipment? How do you grow food where there is no atmosphere? Each solution brings humanity one step closer to living beyond Earth. And perhaps the most fascinating part is this. No single country can accomplish everything alone. Building a permanent presence on the moon requires expertise from many fields: engineers, scientists, doctors, geologists, programmers, robotics experts, materials researchers, biologists. Every discipline contributes another piece to the puzzle. The moon isn't just inspiring better rockets. It's inspiring better technology across countless industries. Some inventions designed for lunar survival may eventually improve life back on Earth. Cleaner energy systems, more efficient recycling, advanced medical technology, smarter robotics. History suggests that investing in exploration often produces unexpected benefits at home. The moon may once again surprise us. But beneath all the excitement lies an unavoidable reality. Competition is increasing. The best landing sites are limited. The most accessible ice deposits are concentrated in specific regions. Every nation wants a place in humanity's next great chapter. That raises difficult questions. Can countries cooperate while competing? Can resources be shared fairly? Will future lunar settlements become symbols of international partnership, or the beginning of new geopolitical rivalries beyond Earth? Those questions have no easy answers, because this isn't just about science anymore. It's about economics, politics, security, and the future balance of power in space. As the first permanent bases begin to take shape, every decision made today could influence generations to come. The rules written now may determine how humanity expands across the solar system. Every great journey in history has faced moments when success seemed impossible. The first sailors who crossed unknown oceans had no guarantee they would ever return. The pioneers who built railroads across continents battled mountains, deserts, and storms. The engineers who dreamed of flying were laughed at because people believed humans were never meant to leave the ground. Today, the moon represents another one of those impossible frontiers. The vision is breathtaking. Permanent cities beneath protective domes, robotic factories operating around the clock, spacecraft launching toward Mars every week, a thriving economy beyond Earth. But between today's reality and tomorrow's dream stands one enormous obstacle: survival. The moon is one of the harshest environments humanity has ever attempted to conquer. There is no atmosphere to protect you, no oxygen to breathe, no wind, no rain, no sound. The sky is always black, even during the day. Without a spacesuit, a human would survive only a matter of seconds. And that's just the beginning. Radiation constantly bombards the lunar surface. On Earth, we're protected by both our atmosphere and our planet's magnetic field. They act like invisible shields, blocking much of the dangerous radiation coming from the sun and deep space. The moon has no such protection. Every astronaut living there would need heavy shielding. Future habitats may be buried beneath layers of lunar soil, using the moon itself as a protective blanket. Imagine entire neighborhoods hidden underground, not because they look impressive, but because that's the safest place to live. Then there's the dust. It doesn't look dangerous. In fact, it appears soft and harmless. But lunar dust is incredibly sharp. Unlike sand on Earth, which has been smoothed by water and wind over millions of years, moon dust remains jagged like tiny shards of broken glass. It clings to everything: spacesuits, machines, solar panels, airlocks, if engineers can't control it. Even the most advanced equipment could slowly wear down. Sometimes the greatest danger isn't a giant asteroid. It's millions of tiny particles working together over time. Another challenge is distance, even traveling at incredible speeds. Messages between Earth and the Moon take over a second to arrive. That might not sound like much, but imagine trying to remotely repair delicate machinery with a noticeable delay after every command. Now imagine medical emergencies, equipment failures, unexpected accidents. Future lunar crews will need to become increasingly independent. They won't always be able to wait for instructions from Earth. In many ways, living on the Moon will be like living on a distant island in the middle of an endless ocean. Preparation will mean everything. Yet despite these challenges, people continue moving forward. Why? Because history has shown that the greatest rewards often wait beyond the greatest risks. The Moon isn't valuable because it's easy. It's valuable because it opens doors that have never existed before. Now picture a normal morning on the Moon 50 years from now. The alarm sounds inside a quiet habitat, buried beneath several meters of lunar soil. Artificial lights gradually brighten to imitate a sunrise. Outside, robotic vehicles are already transporting cargo across the surface. Engineers begin inspecting life, support systems, while scientists prepare experiments that can't be performed anywhere on Earth. A greenhouse nearby produces fresh vegetables using recycled water and carefully controlled lighting. Children, yes, perhaps even children one day learn mathematics while occasionally glancing through thick observation windows at the breathtaking sight of Earth hanging in the black sky. For them, our blue planet isn't the place they live. It's home, far away. That single image changes everything. For the first time in history, humanity would truly become a multi-world species, not visitors, not explorers, residents. Generations born with a different perspective of the universe. Perhaps that's the Moon's greatest gift. Not resources, not fuel, not minerals. Perspective. Looking back at Earth from the Moon reminds us how small our world truly is. No borders are visible, no countries, no politics. Only one fragile blue sphere carrying every person who has ever lived, loved, dreamed, or wondered what lies beyond the horizon. Maybe the future isn't about escaping Earth. Maybe it's about learning how precious Earth really is. The technologies developed for lunar survival may help protect our own planet. Smarter recycling systems, cleaner energy production, more efficient farming, better water purification, advanced medical innovations. History suggests that when humanity reaches for the stars, discoveries often find their way back home. The Moon may improve life on Earth just as much as it transforms life in space. And what about Mars? For decades, people have imagined setting foot on the red planet. But Mars is much farther away than the Moon. A mission there requires extraordinary planning, enormous amounts of equipment, reliable transportation, large fuel supplies. This is exactly where the Moon could become indispensable. Instead of launching every Mars mission directly from Earth, future explorers may first travel to lunar spaceports. There, spacecraft could be assembled in orbit. Fuel tanks filled with hydrogen and oxygen produced from lunar ice. Cargo loaded, systems tested. Then, when everything is ready, the journey to Mars begins. The Moon becomes humanity's launch pad into the deeper solar system, and perhaps one day, beyond Mars, the asteroid belt, the icy moons of Jupiter, Saturn's mysterious worlds, each mission extending the reach of our civilization a little farther into the darkness. It's incredible to think that such a future might begin with a grey world we've stared at since the dawn of human history. For thousands of years, the Moon inspired myths, then it inspired explorers. Soon it may inspire builders, engineers, teachers, doctors, farmers, families. entire communities living beyond Earth. When that day arrives, historians may look back and realize something surprising. The greatest achievement wasn't landing on the moon. It was deciding to stay. So, does the moon really have a secret plan to conquer the solar system? Not in the way science fiction tells us. The moon isn't plotting, it isn't alive, but its unique location, its natural resources, and its low gravity may allow humanity to build a transportation network unlike anything we've ever seen. In that sense, the moon doesn't conquer through power, it becomes indispensable. Every road doesn't lead to the moon because someone demands it. Every road leads there because it simply makes sense. Sometimes the most important places in history aren't the largest cities or the richest kingdoms. They're the crossroads where every journey begins. The moon may become the greatest crossroads humanity has ever built. The next time you step outside on a clear night, take a moment to look up. That familiar white circle has watched over every chapter of human civilization. It witnessed the rise of ancient kingdoms, the birth of science, the age of exploration, the Industrial Revolution, and the first footsteps into space. Now, it may be preparing to witness the next chapter, not as a distant observer, but as humanity's first home beyond Earth. The future may not arrive with a single giant leap. It may arrive one carefully planned mission at a time, one habitat, one launch, one discovery, until one day, what once seemed impossible becomes ordinary, and the moon becomes the place where the solar system finally feels connected. If you enjoyed this journey into the future of space exploration, don't forget to like this video, subscribe to the channel, and turn on notifications so you never miss our next adventure into the mysteries of the universe. Share this video with someone who loves space and big ideas, and let us know in the comments. Do you think the moon will become humanity's first true space hub, or will another destination take its place? Until next time, keep looking up, because the next great discovery might already be waiting above us.